Hello students, in the last session we completed around 10 sums. In this session we will do the next 10 sums, okay? So these sums will mainly be related to momentum conservation and those stuff, and then we will do some sums that are related to friction and those stuff, okay? So we'll do the next 10 sums. Let's see the next one, which is like 11th sum. Let me read the question. You have like a body of mass 3 kg hits a wall at an angle of 60 degree. Fine. So this sum is obviously similar to that of the previous sums that we have seen in the last session. Okay. So you got like a mass which is like 3 kg that hits a wall at an angle of 60 degree. So they have given 60 degree with respect to the wall. Okay. I think that's pretty obvious in the question, in the diagram itself. Returns at the same angle. Fine. The impact time was like 0.2 seconds. So they have given us the time. The force exerted on the wall. So what will be the force that this ball gave to that particular wall? Okay. So whatever it is, the direction doesn't matter, because once you look into the option, it is pretty obvious. You do not have any signs, positive or negative sign. Okay. Therefore, just they're asking us to find the magnitude, right? So it should be clear. Fine. So what we are supposed to find is actually the force. Fine. So from the momentum stuff, we'll be able to get change in momentum. So change in momentum is something that we could actually get from this one. So if I divide it by like 0.2 seconds, the time interval, I'll end up getting the force that was exerted on the wall. Okay, so the sum is pretty similar to that of the previous sums that we have seen in the last session. Okay, so here let me split this component into two components. One will be along the x-axis, right? So you'll have something like this, and then you will get the other component something like this. If this was equal to 60 degree, then obviously this will be my alternate angle. So this one will be like 60 degree, right? Okay, so then what should be this angle? This will be like 30 degree. Fine. So these are something that we have seen already. That's why I'm going quick. So here, if this was like 30 degree, then if I do like momentum, if I do like the momentum along the x, you will have like mv, and then you will have like cosine 30 degree, right? So that will be like cosine 30 degree. Obviously we know the in y direction the momentum is not going to change, therefore change in momentum will just happen along the x-axis, right? So when it bounces back, the condition is just the same thing, therefore the final momentum will be like along the x-axis will be like mv cosine 30 degree, but in the situation that's going to be like minus I cap. In the situation it's going to be like plus I cap, right? So obvious, this is something that we have already seen, right? So that's why I'm just going it quick. You should get this stuff. Okay, right? Anyways, here final momentum minus initial momentum will just give me the negative sign, so that's not needed. Only stuff that is needed over here is the magnitude. Let's leave that sign. So cosine 30 degree, what will be the cosine 30 degree? That's going to be like root 3 by 2. So let me do it straight away. These two stuff will get added. Therefore, I'm just going to put 2. Okay, you should get this stuff. And then 2 times mass into velocity. Mass will be like 3 kg, and then you got the velocity to be like hits at an angle 60 degree. Okay, so V is something. Yeah, they have given the velocity over here, which will be like 10 meter per second. Okay, so you have got the velocity of 10 meter per second. So let me put the 10 over here. 2 into 3 into 10. Then what we have got over here? It's cosine 30 degree, right? So cosine 30 degree will be like root 3 by 2. Okay, so you should be clear with all those stuff. What I'm supposed to find here is actually the force. Therefore, to get the force F, which will be equal to change in momentum divided by the time interval. So I'll have to divide it again with 0.2 seconds. Okay, so let me put that stuff over here. You will have like 0.2. Okay, if I do the cancelling stuff, 2 will get cancelled out. Yeah, 2 will get cancelled out. Then you have got like 0.2. So that will be like 2 divided by 10. So 110 will go to the numerator, and if these two things will get cancelled out, you'll have like 5, 2 divided by 10. Therefore 10 will come to the numerator. Okay, so I'm just done with the cancelling stuff. Now if I just do the multiplication, I'll end up getting the answer. So if I do the multiplication, you have 5 into 10, that's going to be like 50. 50 into 3 will be like 150. So the answer here is 150 root 3. Okay, so the answer will be F, which is equal to 150 root 3 Newton. Right, it should be clear. The option is 1. Okay, You shouldn't have any doubt in this question. Okay, so this is like a simple one. Same exact question that we have already seen in the last session. Okay, you shouldn't have any doubt in this sum. Let's move on to the next one. This sum is based on momentum conservation. Let's see what the sum is. An object flying in air with velocity 20 a cap plus 25 j cap minus 12 k cap. Okay, so they have given us the velocity of that particular object suddenly breaks into two pieces. Okay, so it is breaking into two pieces with the masses or in the ratio 1:5. Okay, so let me put it this way. If the total mass was equal to 6m, then after it has broken apart, you will have the mass to be like 1m is to 5m. That's how I'll have to split it. Okay, so that's what they have given over here, which is like 1:5. Okay, that is done. Then you have got like the smaller mass flies off with velocity 10 I cap. They have given you the velocity of the smaller mass. What they're asking us to find is the velocity of the larger piece. Okay, so it should be clear that the momentum will be conserved. Initial momentum will be equal to that of the final momentum because you have gotten mass. Okay, so it is just traveling with some velocity v. Then you don't have any external force acting on this particular object. Because of the internal forces, this is going to split into two masses, okay, of different size. It doesn't matter. So when this stuff is about to explode into two pieces, what will happen? The smaller mass will give a force to the bigger mass, and the bigger mass will in turn respond to the smaller one. Okay, so these two forces will be like equal and opposite to each other, and this is the complete system. Okay, you do not have any external force acting on this particular mass, therefore these forces are equal and opposite to each other. Okay, so we might have seen this one in the collision stuff. Okay, so while doing that momentum conservation, I just used the Newton's third law and we found like law of momentum conservation. Okay, so in that situation, the forces were equal and then opposite. So whenever you have a system and you consider it completely, in that situation, obviously you will not have any external force acting on it. Everything will be internal. Okay, so one will push the other forward, the other one will push the first one other way around. Okay, backwards. Okay, so forces will be equal and opposite. Therefore, momentum will be conserved in all the situation. Okay, the energy will not be conserved because initially it would have traveled at some velocity, then because of some chemical stuff or whatever it is, it would have gained some extra kinetic energy and all those stuff. Okay, so in those situations, when you do not account into any other chemical energy stuff or something nuclear energy stuff, in that situation energy will not be balanced. Okay, so obviously in the next chapter we will do like elastic collision, elastic collision and all those stuff. Okay, so in those, while doing those sums, in all those things, momentum will be conserved, but depending on the situation we will take the energy conservation. Okay, but in the situation it is pretty obvious energy is not conserved. Only stuff that's going to get conserved is momentum. So by using the momentum conservation, I'll be able to get the answer. Okay, so let's do this sum. Fine, you should be clear. So it is pretty obvious. Forces are equal and opposite, and entire thing was a single system. That's how I considered it. Therefore, initial momentum will be equal to that of final momentum. Okay. So initial momentum will be equal to final momentum. So let me consider the initial momentum. So while considering the initial momentum, they have given us the velocity straight away, no problem. And the mass will be like 6m. Okay, so that will be my initial momentum. While doing the final momentum, what they have given us, like they have given us the velocity of the second smaller mass, which is like m, and then 5m, it will be the larger piece. For that 5m, the velocity is something that I need to find. Okay, so if we just put in plug in momentum for the initial and then the final stuff, the only parameter that will be unknown will be the velocity of the larger piece. If I just do the rearrangement thing, I'll end up getting the velocity of the larger piece. Okay, it should be clear. Okay, let me do the sum, you'll get it. So the first thing is like 6m. Okay, and then the velocity will be like 20 I cap, 25 j cap. So the velocity will be like 20 I cap plus 25 j cap. It should be clear. And then minus 12 k cap, minus 12 k cap, which will be equal to, that's the initial momentum, which will be equal to that of the final momentum. So to get the final momentum, you will have mass, which will be the smaller piece, and then you will have 100 I cap, that will be the velocity. So you will have like 100 I cap plus 35 j cap plus 8 k cap, and then u2 will have plus 5m, that will be the larger one, and then the velocity is something that I need to find, okay? So that will be my unknown velocity vector v. So if I do the rearrangement thing, I'll get the unknown velocity vector v. That's going to be my answer, okay? So let me do the cancelling stuff. You have m will get cancelled out. Do the rearrangement and do the rearrangement stuff, you'll get the vector v, okay? So if I do the rearrangement stuff, you'll have like 5 vector v, which was equal to 6 into 2. That's going to be like 120 I cap, right? So when this stuff comes to the left hand side, you'll have like minus 100 I cap. So 120 minus 100 will give me like 20 I cap, okay? The first part is done. So the next one will be like 60 plus 60 into 25. That's going to be like 150, right? Okay, 150 j cap, and then I'll have to subtract it with minus 35 j cap, right? So 150 minus 35 will be like 115, okay? Yeah, let me put it straight away. So you will have like plus 115 j cap. That stuff is done. Then you have got like 6 into 12. That's going to be like 60, 72, right? So you'll have like negative 72 k cap, and then this stuff will get added to it, right? So when this thing gets added to it, you'll have like minus 80 k cap, okay? So you got like minus 80 k cap, right? If I just divide it with 5, I'll end up getting the answer. So we'll have like vector v, which was equal to the first one, 20 divided by 5 will give me like 4 I cap plus 115 divided by this stuff will give me like 23 j cap, right? So yeah, so that will give me like 23 j cap minus you will have like 16, yeah, yes, so I'll have like minus 16 k cap. So the answer will be 4 I cap plus 23 j cap minus 16 k cap, which will be option 1, right? So it should be clear. You should get this sum, okay? So in this sum, I just did the momentum conservation. Initial momentum was equal to the final momentum. So only parameter that was left was velocity of the larger piece, okay? So that was like the x that I need to find over here. So rest all other parameter was known. So I just substituted it and solved it. I got the answer, right? You shouldn't have any doubt on the sum. Let's move on to the next one. This sum is also based on momentum conservation. Let's see what the sum is. An explosion breaks a rock into 3 parts, okay? So obviously you're having an explosion, then obviously I'll be able to do the momentum conservation. So here it is going to break into 3 parts, okay, in a horizontal plane. Fine, 2 of them goes up at right angle to each other. So it should be clear, it is like horizontal plane, which means a kind of 2-dimensional stuff, okay? So only component that comes into picture will be like I cap and j cap, okay? Got it? So 2 of them goes up at right angles to each other. The first part of mass 1 kg moves with the speed of 12 meter per second, and the second part moves of mass 2 kg moves with the speed of 8 meter per second. If the third part flies off with 4 meter per second speed, then its mass is, okay? So in every single instant, it should be clear they have given us the magnitude of the velocity, okay, which means they have given us the speed. Got it? And the splitting is obvious, right? So it will be like 1 kg and the next one will be like 2 kg, okay? So what will be the mass, final mass? That's what I need to find over here. So what will be the mass of the third part? That's what I need to find, okay? So obviously even in this situation, I'll have to do the momentum conservation. Therefore, you will have initial momentum Pi, which will be equal to that of the final momentum straight away. Initial momentum should be equal to the final momentum. So what was the initial momentum? An explosion breaks a rock into 3 parts, okay? Which means initially it was at rest. The entire rock was at rest, then it got exploded into 3 pieces, okay? So what should be the initial momentum? Initial momentum is obviously 0. I'll have to just plug in the final momentum. So in the final momentum case, I know the momentum of the first mass, second mass, and the third mass. I know the velocity. Only stuff that I need to get over there is the mass, okay? So if I just plug all those things into it, I'll end up getting the answer, the mass, okay? Got it? If needed, I'll convert the momentum to scalar quantity so that I'll be able to get the mass, okay? Because obviously mass is a scalar quantity. If you have vectors into it, then to get the mass, I'll just convert that entire momentum to scalar. We'll do that stuff. While doing it, you'll get it, okay? So here you have got like initial momentum that was equal to 0, okay? So let me draw a diagram. So to give you a clear picture, you have got a rock, okay? So this rock splits into 3 pieces. Got it? So the one will be of 1 kg, and these two pieces will move at right angles to each other. Okay, so here you have got the one mass which is going to move in j cap direction. Let me put it that way, and the other one which is going to move along the I cap direction. Okay, so obviously this will move at certain inclination. Okay, so this will be the momentum of the third mass, which is something unknown. That's what I need to find over here. Okay, so let me take it this way. 1 kg mass is moving along j cap, and then 2 kg mass is moving along I cap. Okay, so these two things are consideration because they have given us clearly that these two things goes up at right angles to each other, which means those two things should be at an angle of 90 degree. Okay, so everything is done. Let me do the solving. So here initial momentum was like 0, which will be equal to the final momentum. So what will be the what are all the final momentums that you have got over here? You will have vector p1, and then you will have like vector p2, and then you will have like vector p3. Okay, so here if I do the solving, you will have 0, which will be equal to the momentum, right? So the first one will be like 1 kg, and then it moves with the speed of 12 meter per second j cap direction. Okay, so you will have 1 kg, mass will be like 1 kg, it moves with the speed of 12 meter per second along j cap direction. So the first one is done, and then vector p2, so that will be like 2 kg mass flies off with the speed of 8 meter per second, so that is 2 into 8 I cap. Okay, right, whatever the component, it doesn't matter, the only thing that matters is the magnitude. Anyway, we'll change this one to magnitude plus vector p3. Okay, so what will be the momentum of the third mass? That's what I need to find over here. So you will have vector p3, that will be equal to, just flip the signs, you'll get the answer, minus 12 j cap minus 16 I cap. Okay, so that will be the vector p. What they're asking us to find is actually the mass, right? So to get the mass, they've given us the velocity, which will be equal to 4 meter per second. So to get the mass, what should I do? If I get the magnitude of this one, mass times the velocity, that magnitude will give me the momentum, right? So if I just get the magnitude of this one, I know the velocity. From this, I'll get the magnitude of momentum. Obviously, I'll be able to get the mass from that stuff. Okay, so let me find the magnitude for this particular momentum, which will be like p, that is equal to root of negative 12 the whole square, that's going to be like 144 plus 16 into 16. Okay, let me do the multiplication. You'll have like 16 into 16, 36, yeah, 9, and then you'll have like 16, so 6, 5, 256. Okay, so here you'll have like 256. Let me add it with like 144, so you'll have 0, 1, 0, 1, that's going to be like 400. Okay, so the momentum of the third part, the magnitude of momentum of the third part will be like 20. Got it? Yeah, so now I have got the momentum. From this, I'll have to get the mass, right? So you'll have like m times v. The mass is something that I need to find. The velocity is 4. Okay, so 4, which is equal to 20, therefore mass will be equal to 5 kg, right? The answer here is 5 kg, which is like option 4, right? This sum should be clear. So what we found over here is the initial momentum was known, which will be equal to 0, and the final momentum is something with which I need to do the solving. Okay, so there I just know the momentum of two part, the third part has to be found. Okay, the mass of the third part has to be found. So from that I found the momentum of the third part vectorially, and then I just converted it to the magnitude from which I got the mass. Okay, it should be clear. There shouldn't be any doubt in the sum. Let's move on to the next one. This sum is also same as that of the previous one. Let's do the solving. We have got a 1 kg stationary bomb is exploded into 3 parts having mass 1 is to 1 is to 3 respectively. Okay, so they have given us the ratio over here. So we need to find like parts having mass of the same mass move in perpendicular direction with the velocity 30 meter per second. Okay, then the velocity of the bigger part will be, okay, so same as that of the previous sum. So you have got a mass that's going to split in this fashion. Okay, so you're having a mass that's going to split in this fashion. So two pieces, same mass, which means like both those mass which has the same m. Okay, 1:1, which will be like m. These two things flies off at right angle to each other. Okay, moves in perpendicular direction with a speed of 30 meter per second. So they have given us a velocity which will be equal to 30 meter per second. So this stuff is also done. What they're asking us to find is the velocity of the bigger part. Okay, so they're asking us to find the velocity straight away. So I do not want to worry about the mass. Okay, let's do the solving. You'll get the answer straight away. Okay, so the initial momentum will be equal to the final momentum, obviously. So you'll have like pi, which will be equal to the final momentum. Initially it was stationary, okay, which means initial momentum will be 0. So that stuff is done. So if I do the solving, you'll get the answer. Okay, so 0, which will be equal to the mass m, and the velocity was like 30 I cap. Yeah, and the next one will be like m, that's going to be like 30 j cap, and then the momentum of the third one. Okay, so for the third one, it will have like 3m. Let me put the mass straight away. Okay, so 3m, and then the velocity vector v. Got it? So what they're asking us to find is the magnitude of this velocity, right? Just do the rearrangement thing, you'll get the answer. Simple sum. So m will get cancelled out. Vector v will be equal to, so you will have something like this. Vector v will be equal to 30 I cap, 30 j cap. So I'll have to divide it by 3. Therefore, you'll have like 10 minus 10 I cap minus 10 j cap. That gives me the velocity. I just need to find the magnitude of this velocity. Therefore, that will be like modulus of vector v, which will be like root of 10 square, and then 10 square, that gives me like 100. Yeah, so that will be like 200. So you will have 10 root 2. That is my answer, which is like option 1. Okay, so the answer for this question is like option 1. You shouldn't have any doubt in this sum. This is same as that of the previous sum. It should be clear. Let's move to the next one. Next sum is a mass of 1 kg is thrown up with the velocity of 100 meter per second. Okay, so that is a 1 kg mass which I threw it up with a velocity of 100 meter per second. Okay, after 5 seconds it explodes into two parts. So after 5 seconds it exploded into two parts. One part of mass 400 gram comes down with a velocity of 25 meter per second. So they have given us the velocity of one part, which is like 400 gram. Obviously the other one will be like 600 gram. Okay, the velocity of the other part is, so I just need to find the velocity of the other part, which means 600 gram parts velocity. Okay, got it? So it should be clear. So here what I need to get is actually the initial momentum. That is something that also needed to be found out, because here the initial momentum is not equal to 0. They have given us some condition. A mass of 1 kg is thrown up with a velocity of 100 meter per second. After 5 seconds it got exploded. Okay, so I'll have to get the velocity of this particular mass after 5 seconds. So they have given us the time also. So obviously this is thrown in the earth surface. They have given us the gravity g, that to be taken as 10 meter per second square. Therefore, I'll be able to use the kinematic equation. I just need to find the final velocity. Time is given. Therefore, it will be like v equals u plus ad. This is the formula that I need to put in. So here, what will be the final velocity? That's what I need to get over here. So v, which will be equal to u, is thrown up, which means in positive direction. Therefore, that will be like 100 positive up. Okay, plus at. So that will be obviously negative 10. Okay, downwards, because acceleration is actually acting downwards, negative 10, and then t gives me like 5. So the velocity of that object will be like 50 meter per second traveling upwards. So after 5 seconds, this 1 kg mass will be traveling upwards with a speed of 50 meter per second. So this is the initial momentum that I need to consider. Okay, so I'll have to freeze that mass after 5 seconds. So in that instant, it will have a velocity of 50 meter per second. Therefore, this part is done. J cap. The two, it is up traveling upwards. Therefore, if I plug in the vector stuff into it, it will be like upwards. Therefore, this is going to be like plus j cap. Okay, so everything is done over here. Next, what I need to do is to equate the initial momentum with the final momentum. Okay, so pi should be equal to the final momentum pf. Okay, so here if I do the solving, you'll have mass which will be equal to like 1 kg, and then the velocity of that particular mass will be like 50 j cap. Got it? So this is the initial momentum, which will be equal to that of the final momentum. So what they've given here regarding the final momentum is one part has a mass of 400 gram, which will be like 0.4 kg. Got it? It has a velocity of 25 meter per second. That too, this is like acting downwards, minus j cap. Correct? Yes, down. Therefore, it is like negative j cap plus the other mass will be like 0.6, and I'll have to get the velocity of that particular mass. That's the unknown which I need to find. Okay, so if I just do the solving and take root out of it, I'll end up getting the magnitude. Okay, so let me rearrange this stuff. If I do the rearrangement thing, you'll have 0.6. Yeah, so this thing comes to the right left hand side, so you'll have like 50 and then 0.4 into 25. Yeah, got it. So that's 4 into 25 will be like 100, and then that's going to be like 10. So these two things will get added. You will have like 60 j cap, which will be equal to 0.6 vector v. Okay, yeah, so vector v will be equal to, so divided by 0.6, so 6 will get cancelled out, 1 by 10, so that's going to be like 100 j cap. Okay, so now I have got the velocity which is equal to 100 j cap. Okay, so obviously this is only along the j cap, which means along the y-axis. Therefore, it's a kind of one-dimensional stuff. I do not want to take the root to get the magnitude, so I'll be able to match it straight away. The velocity, the magnitude of the magnitude of velocity of the other part will be like 100 meter per second. That will be acting upwards. So the answer here is option 3, right? The sum should be clear, right? I just found the initial momentum. Then what I did is the same thing, equating initial momentum with the final momentum. That gave me the answer. Okay, it should be clear. Let's move to the next one. Next sum is a particle moving with velocity vector v is acted by three forces as shown. Okay, by the vectors, by the vector triangle PQR. So they have given us the direction of force in the diagram. The velocity of the particle will be, okay, so you have got a particle, and then these three forces are acting on that particle. If that was the case, then what will be the velocity with which this particle is going to change? Okay, so here obviously this is like a statement based question, so in which direction it's going to change, that's what I need to find. Okay, whether it is going to increase, decrease, or remains constant, whatever it is. Okay, so if these were the three forces that is acting on the object, what will I do? I just do the vector addition of all those stuff. I'll end up getting the answer, right? So here you have got vector, so here you have got like two perpendicular component. One is like towards the negative I cap, and the other one will be like towards this one. Okay, so if I have to add these two stuff, what will I do? I'll just put the tail of one vector and the head of the other one. Okay, so one vector is towards the left and the other one will be towards the top. Okay, towards the up. So the final velocity of these two vectors will be this one. Yeah, got it. So this thing, obviously this is inclined upwards and the other one is like downwards. Okay, so therefore the summation of these two vectors will give you the vector that is opposite to the direction of the PQ vector. Okay, so it is pretty obvious, right? You do not want to do like overthinking into it. This is like simple, straightforward, okay, question. So when you add these two vectors, you end up getting the resultant vector that is actually oriented opposite to that of this vector. Okay, so therefore if I do the addition of these three vectors, I'll get the answer to be like 0. Okay, so one vector is actually inclined upwards and the other one is like directed downwards. Okay, so these two things will cancel out each other. Therefore the summation of all these three vectors will be equal to 0, right? It is pretty obvious, right? Therefore the velocity, as the forces balance each other, the velocity of the particle will not change. It's going to be constant. Fine, simple sum. You shouldn't have any doubt. The answer here is option 4. Let's move on to the next one. This sum is also based on force balancing stuff and then resolution of vectors. Okay, let's see what the sum is. Three forces acting on a body are shown in the figure. Okay, so you're having an object, same way. There are like three forces that is acting on this particular object as they've given in this graph. Okay, as shown in the figure. First statement is done. Then you have got to have the resultant force only along the y direction. So once you add all those three forces, you should have resultant force only along the y, which means along the x, the summation of force should be equal to 0. Okay, the magnitude of minimum additional force needed is, okay, so what should be the extra force that I need to give, so that I'm just going to have only the force along the y direction, which means here in this case what I should do is I should balance the force along the x, which means if let me put it this way, if I have like 5 Newton after adding all those forces, if I just have 5 Newton along the x-axis, okay, then what should I do is I'll have to give 5 minus 5 Newton to balance this one. Okay, so that's what they're asking us to find. The magnitude of minimum additional force needed is, once you sum up all those three vectors, obviously from the option it is pretty clear, you will have like some extra force that is along the x. It could be along the plus or minus, it doesn't matter. So if you get the answer to be like plus 5 Newton or something like that, I'll have to give the same amount of opposite force. Okay, so the magnitude is something that they're asking us to find. Therefore, whatever direction you get, you just put the positive value of it. That will be my answer. Okay, so I just need to balance only the forces along the x. I do not want to worry about the forces along the y. So that stuff is done. So only thing that I'm going to balance over here is the forces along the x. Okay, this should be clear. So what I need to get is actually the force that is along the x. Okay, so therefore if I do the resolution of vector for all those components that is over here, here you will have this component to be like 4. So this is like sine component, right? Because this one will be like my cosine component, that is not needed. Only stuff that I'm worried about is the sine component. So that will be like sine 30 degree. So what is like sine 30 degree? Yeah, sine 30 degree will be like 1 by 2. So 4 into 1 by 2. So that will give me this component. So this stuff is done. Then you have got like the other one, which will be this one, because of this one. Yeah, that will be 1 into sine. Yeah, that's like cosine, right? So 1 cosine 60 degree. So 1 cosine 60 degree is again like 1 by 2. Therefore, that will be 1 into 1 by 2. The next one. So here you have got like 2. Okay, so these two are like cutting each other. Yeah, okay, so those two are like straight lines. Therefore this and this should be same, because those two angles are like opposite angles. Therefore you will have this thing to be like 30 degree. Yeah, okay, so this one will be like 30 degree. Got it? So what should be this component? So if this was like 30 degree, then obviously this one will be like 60 degree. Okay, because together it forms like 90 degree. Therefore you should get this stuff. Yeah, so therefore you will have like one more component, which will be like 2 cosine 60 degree. Yeah, got it. So that will be like 2 cosine 60 degree. Again it gives you like 1 by 2. So 2 into 1 by 2. Okay, it should be clear. Now I have got all those components that is along the x-axis. I'm just least bothered about the y, because I'll just have to balance the forces along the x, right? So let me do the solving over here. So summation of forces along the x, summation of forces along the x, that's what I need to get. Okay, so you have got over here half I cap, and then you have got like one more component, which is like plus 1 I cap negative of 2 I cap. Okay, so when I do summation of all those things, summation of force along the x will be like 1.5 minus, that's going to be like minus 0.5, negative 0.5 I cap. Okay, so you are having a force that is, when you do the summation of force along the x, you are having a force that is directed towards the negative x-axis of 0.5. Okay, so then what should be the force that I need to add? I just need to give 0.5 Newton along the plus x-axis. Okay, so if I give that force, then obviously force along the x will get balanced. Only force that will be left will be along the y. So they have given us clearly the resultant force should be along the y direction. If it was there or wasn't there, that's not a problem. The thing is, I'll have to balance all the forces along the x. Okay, therefore I'll have to give a force of 0.5 I cap along the positive direction. So that's going to be option 3 will be my answer. Okay, right, you shouldn't have doubt in the sum. Simple easy sum, right? It should be clear. Let's move to the next one. Next sum is statement based sum, and that out is based on friction. Let's see what the sum is. Which one of the following statement is incorrect? Okay, so this is important. They are asking us to find the wrong statement. Okay, incorrect statement. Let's see the first option. You have got rolling friction is smaller than the sliding friction. Yeah, obviously, rolling friction will be very less when compared to the sliding friction. Okay, so sliding friction actually means motion, therefore it is like kinetic friction. So it is obvious rolling friction will be the lowest. Okay, for the for that particular geometrical shape, you'll have the lowest friction when compared to rest all other shapes. Okay, so that is the special case I've already told you in the theory. So it should be clear. Rolling friction is smaller than sliding friction. That is correct. Okay. So then you have got limiting value of static friction is directly proportional to the normal reaction. So here they have given you the limiting value, which means the maximum static friction that is possible in that particular surface. Okay, so that's the highest level of static friction that the surface could give on that particular object. So limiting value of static friction is directly proportional to the normal reaction. Obviously that is right. Okay, so Fs will be equal to mu s capital N. It depends on the normal reaction. So that too, it is directly dependent. So option 2 is also correct, which is not the answer. Okay, so then you have got frictional force opposes the relative motion. Yeah, that's obvious, right? So it opposes the motion of the particular object. Therefore, frictional force opposes the relative motion. Yeah, that is right. Next, let me check the fourth option. Obviously, that should be my answer. Anyway, let's check it. Coefficient of sliding friction has dimension of length. Okay, so this is something that I need to verify. Okay, so here you have got like coefficient of sliding friction, which will be like mu k. Yes, so you have got the frictional force, which is like Fk, which will be equal to mu kn. So here in this situation, coefficient of sliding friction, which will be like F is the force and normal reaction is also force. Mu k is the coefficient of sliding friction or kinetic friction. Okay, so here it is pretty obvious, force on the left side and then the force on the right hand side. Okay, so here you got like Newton, here you got like Newton, these two things will get cancelled out. So mu k is actually a dimensionless quantity. Okay, so it doesn't have any it doesn't have any units into it, so it is dimensionless. But what they've given over here is coefficient of sliding friction has dimension of length, so it doesn't have any dimension. Therefore option 4 is my answer, right? It should be clear, right? Simple sum, simple statement based logic sum. You shouldn't have doubt. Let's move on to the next one. This sum is little bit lengthy and also tricky one. Let's see what the sum is. A plank with the box on it one end is gradually raised above the other end. Okay, so what I'm doing over here is I'm just going to lift the plank at certain inclination. So and then you do have a box on that particular plank. That's what I'm going to do. Okay, as the angle of inclination with the horizontal reaches 30 degrees. So when you're going to incline this one and when it reaches like 30 degree, what happens is the box starts to slip. At 30 degree, the box will start slipping. Got it? Okay, so what they've given over here is that will be the point where it starts slipping, which means that angle is actually the angle of repose. We have discussed this one exhaustively in the theory part. So that particular angle, by using that particular angle, I'll be able to get the mu s, coefficient of static friction, that will be equal to tangent theta max. So in that particular instant, it will start to slip, which means both those forces, static friction which was acting upwards and the mg sine theta which was acting downwards, those two things will get balanced each other. Therefore, if I'm just going to give a slight push to it, it will start moving, okay, with that constant velocity. Okay, but here next what they've given over here is actually the box starts to slip and slides 4 meters down the plank in 4 seconds. Okay, which means once the slipping starts, what will happen? The kinetic friction will come into picture. Okay, because it started moving, therefore you'll have like mu k, which means mu s will be the greater one, mu k will be a little bit less when compared to that of the mu s. Okay, so mu k will be a little bit less, obviously, right? Therefore, so once it starts moving, the frictional force will become lesser, where in the case of the mg sine theta, that will be still the same thing. Okay, therefore you'll have like some extra acceleration with which it will start moving downwards. Okay, initially as mu s was as like fs, static friction was greater, those two things got balanced. When the angle was like 30 degree, it started slipping, which means I just gave a little bit push to it. So when I just gave that one, so it started accelerating, because once the object starts moving, it becomes like kinetic friction. Okay, therefore kinetic friction will be less when compared to that of the static friction. But in the case of mg sine theta, it is still a constant one. Okay, so obviously mg sine theta will be a little bit greater, so it will start dominating. Therefore you will have an acceleration downwards, with which it will start accelerating downwards. With that acceleration, it was able to slide 4 meters in 4 seconds. Okay, so with that small increment in velocity, it was able to travel down 4 meter in 4 seconds. So that's what they've given over here. What they're asking us to find is the coefficient of static and kinetic friction between the box and the plank will be. Okay, so I just need to get the coefficient of static and then the kinetic friction. From intuition, we know that coefficient of static friction will be a little bit greater when compared to kinetic friction. Okay, Let's verify with the option 0.5 and 0.6. This is not possible because static has to be greater. Okay, so first one is done. That's not possible. Okay, so first one is opted out. Then you have got like 0.4 and 0.3. That thing is possible. Okay, 0.6 and 0.6 same value. That too is not possible. 0.6 and 0.5, either it should be like option 2 or it should be like option 4. So from those two, one should be the answer. Okay, from those two things. Okay, so first let me get the easy one, which is like mu s, that will be equal to tangent theta max. Yeah, so straight away, yeah, I got it. So that will be like tangent theta max will be like tangent 30 degree, which will be equal to 1 divided by root 3. Yeah, so 1 divided by root 3 will be like 1 divided by 1.732. That's going to be like 1 divided by 1.7. So if I do the solving for that one, it will be like 10 divided by 17. Yeah, 0 point, you'll have like 100. So 17 into 5 will give me 7 by 35, 3, 85. So that will be like 85. So that will give me like 5. Yeah, so 15, 150. So 17 into 8 or something, 40, 48, no, 56, 5. So that will be like 136. So 136, yeah. So that will be the closer one. So 0.58 or 59. So we'll get something. Yeah. So 151 will be the next one. Therefore, it will be no. So it will be like 136. If I do the subtraction, I'll get like 14 or something like that. So it will be like 0.58 or 59. So that's the closest approximation. Okay. So mu s will be equal to 0.58. So if I do the approximation over here, it should be equal to 0.6. So that is the only option that is possible to check over here. Therefore it will be like either it should be 0.4 or 0.3 or 0.6 or 0.5. Obviously if I round it off, you will get 0.6. Okay, so option 4 is the answer, which is like 0.6 and 0.5. Okay, now I have got the answer based on the coefficient of static friction, because kinetic friction should be less when compared to that of 0.6. Okay, so then obviously it should be like 0.5. Okay, this stuff should be clear. Now what I'm going to do is I'm just going to find the coefficient of kinetic friction. So how should I find that one? Let me solve that one. So you'll have an idea how to find the coefficient of kinetic friction. Okay, so anyway, the option is the answer is option 4. That is done. Now let me verify it whether the coefficient of kinetic friction is actually 0.5 or not. Okay, let me do the sum. So here you have got a plank. Okay, this one is at the inclination of 30 degree, and then you have got an object over here. Okay, this stuff is going to slide. Got it? So this will be my mg. Okay, so if I do the resolving, you'll have like two component. So this thing will be like theta, therefore this will be like mg. That's going to be like cosine 30 degree, right? Okay, let me put it straight away. Cosine 30 degree. So this will be like mg sine 30 degree. Then you have like one more component into it, that will be the normal. So that one will completely balance the mg cosine 30 degree, and then you have got like the backward force that is acting opposite to that of mg sine theta, that will be like kinetic. Once it starts moving, you'll have like kinetic friction. Obviously this kinetic friction will be less when compared to static, therefore mg sine theta will dominate when compared to this fk. Okay, so what I need to find here is actually the acceleration. So what is the acceleration with which it is actually moving downwards? If I get that one, what I could do is I could use like any kinematic equation, and then I'll be able to get the mu k. Okay, so that thing is possible, right? Because obviously in the question what they've given is like 4 meters, they've given us the length and then the time. Okay, so distance covered by that box is given, same way the time is also given. So the kinematic equation which I could use is the second kinematic equation. That is possible, right? So first let me do the force balance along the x, which means along this inclination. Okay, so the y is obviously done. N will be equal to mg cosine 30 degree. So that thing is straight away. So if I do the force balance along the x-axis, I'll get the acceleration, required acceleration, right? So that one more step is left. So if I do the force balance along the x, you will have friction Fk. Let me write it down. So you will have friction Fk that will be actually acting upward. So that's going to be like plus I cap, and then you'll have like plus mg sine 30 degree. So mg sine 30 degree or sine theta, whatever it is, I'll put it sine theta itself. So mg sine theta, that will act actually downwards. Okay, so that will be like minus I cap, which will be equal to ma. So the acceleration is obviously acting downwards. Okay, so in this situation, I'm just going to plug in the direction. Therefore, you'll have like ma. So that is going to get accelerated downwards. I know that stuff straight away. Okay, so this entire object is going, the final acceleration of this object is going to be downwards. Therefore, this will move downwards. Okay, therefore, I just put it straight away, which is equal to not zero, because this is not in static condition. It started accelerating. Therefore, that too along the negative direction, which is like minus I cap. When I do the solving, I'll get the answer to be positive because I have plugged in the negative sign over here. Okay, it should be clear. I just plugged in all those direction properly. So the unknown that I need to find here is the acceleration. I have already given the direction negative. Therefore, I'll get the answer A to be positive. You should get the logic, right? We have solved more sums. It should be clear. Okay, so let me do the solving. You'll have acceleration to be, you'll get the acceleration to be like something. Before that one, Fk, I'll have to solve this stuff, right? So instead of Fk, what I could do, Fk is like mu kn, right? Friction will be equal to mu kn. So obviously these two things will balance each other. Therefore, instead of n, I'll substitute like mg cosine theta. Okay, let me write one more step to it. So you'll have mg cosine theta, yeah, mu k mg cosine theta, mu k n. So it should be like mu k mg cosine theta, which was equal to plus mg minus mg sine theta, which will be equal to minus ma. Okay, let me take those let me take out all those I component. Okay, it's one dimensional obviously. Now let me cancel out all those m will get cancelled out. If I do the rearrangement thing, I'll get the answer for the acceleration. So the answer for the acceleration A will be equal to this. When this negative sign goes to the left hand side, becomes, the negative part becomes positive and the positive one becomes negative. Therefore, you will have A, which is equal to g sine theta negative of mu kg cosine theta. Okay, so now I have got the acceleration of this object, magnitude of acceleration. Obviously the answer will be positive because I've given all those directions properly. Okay, therefore I've got the magnitude of acceleration with which it is going to travel downwards. That stuff is done. Okay, then what I'm going to do is, so this part is done. Then what I need to find is, now I've got the acceleration, what I need to actually get is the mu k. Therefore what I'm going to do is, I'm just going to put the second, I'm going to take the second kinematic equation, which will be s, that was equal to ut plus half ad square, right? So s, which will be equal to ut plus half at square. Initially, the initial velocity was 0. Therefore, this term goes to 0. So the first one is done. Then what they've given is, it traveled a distance of 4 meters downwards. Okay. So that should obviously be the negative 4. Negative 4, which will be equal to half. What was the acceleration? It was equal to g sine theta mu k minus mu k g cosine theta. Okay, so this entire term is positive, but in this situation I've just plugged in the direction minus. Okay, so how is the acceleration actually acting in this direction? This direction, it is acting downwards. Therefore I'll have to put a negative sign into it, right? It should be clear. Okay, I just know the acceleration is actually acting downwards. Fine, therefore this just gives me the positive term. It should act downwards. Fine, so therefore I'll just plug in the negative sign over here. So you'll have, you should be clear with the sign convention that I'm using over here. Don't get confused. So you'll have like negative g sine theta minus mu kg cosine theta, and then you got the t time. What they've given over here, it's like 4 seconds. So all those things is like same for, okay? Yeah, therefore that too will be like 4 square. Okay, what will happen over here is 1 4 will get cancelled. One of this one will get cancelled out. These two things will become positive, and you'll just be left with only 1 4. If I do cancel that stuff, we'll get like 2. Okay, so that thing is done. Next, if I just plug in the g 10 or 9.8, and then if I just put in the theta over here 30 degree, I'll end up getting the answer, right? So mu k will be the only part which is left, right? So here, let me round it off. I'll just put 10 over here and let me do the solving, okay? So if I do the solving, you'll have 1 which was equal to 2 into, instead of g, I just put in 10 into sine theta. So sine theta is like 30 degree, right? Obviously at 30 degree it started sliding. Therefore, the theta will be equal to 30 degrees. So that will be like sine 30 degree, right? So sine 30 degree will be 1 by 2 straight away, minus mu k. Instead of g, I'll put in 10, and then cosine 30 degree will be like root 3 by 2. Yeah, yes, root 3 by 2. Okay, so now what will happen is, let me cancel those two. Cancel out those two. Okay, if I just factor out 2 from this one, 2 2 2 will get cancelled out, right? So you'll just be left with 10 minus, yeah, 10 root 3 mu k. Okay, so if you do the rearrangement thing, you'll get the answer. That's it, finished. So 10, if this one 10 goes to the left hand side, you'll have like 1 minus 10, that's going to be like negative 9, which will be equal to minus mu k 10 root 3. Okay, so these two things will become positive. Therefore you will have mu k, which was equal to 9 divided by 10 root 3. Yeah, so 9 divided by 10 root 3 will be something like this. Mu k, which will be equal to 0.9 divided by root 3. Yeah, okay, so that's how it should be, right? 0.9 divided by root 3. Yeah, if I have taken it to be like, instead of this one, if I just take it as if like 9.8, you will have like 9.9 divided by 9.8 root 3. Okay, so now I have just rounded it off, so you have got something like 0.9 divided by root 3. Let me check it with the above one. So here you have got 1 divided by root 3. Here you have got like 0.9 divided by root 3. Obviously this value is less, because once you compare the numerator, you'll get it. This value is obviously less when compared to this one, which is like 1 divided by root 3. Okay, if this gives you the answer to be like 0.58, then obviously this will give you answer somewhere around like 0.5253, something like that. Okay, so it is pretty obvious mu k is actually less when compared to that of the mu s. Just do the solving, 0.9 and then divided by 1.7. You do the division stuff, you'll get the answer closer to 0.52 or 0.53, something like that. Then obviously mu k will be equal to 0.5, right? So it should be clear that mu k is less when compared to the mu s. We do not want to solve the second part of this question, because that is pretty obvious. If the first one was like 0.6, then the second one should be less when compared to this 0.6. Then obviously that should be like 0.5. Okay, anyway, I've told you how to solve this sum. So to solve this sum, what I did is, I just took that inclined plane and then I just got that angle of repose. Okay, so from that angle of repose, what I was supposed to find over here is the acceleration with which that particular box is going to slide down. That's what I need to get, right? So to get that acceleration, I did the force balance stuff and I got the acceleration, particular acceleration with which it was accelerating downwards, because at that instant, once it starts slipping, obviously what will happen over there is, acceleration is mg sine theta will be the same, but the thing is mu s will become fs will become like fk friction due to the kinetic stuff is actually less when compared to the static friction. Therefore you will end up generating slighter acceleration that will drag that particular object downwards. Okay, so that thing is done. Therefore, with that acceleration, it will start accelerating downwards. Now I have got that acceleration, and then I plugged in all those signs and convention into it. You should get that stuff. Okay, so from that acceleration, I took the answer to be like positive because I just substituted all those signs properly. Therefore, I'll get the acceleration positive. So once I'm about to use it in the kinematic equation, I'll have to plug in all those directions. Therefore, I just put one more negative sign into it, and then I did the solving, right? So solving is a little bit tricky and it was lengthy. Okay, once you ended up solving that stuff, you got the answer mu k. Obviously, when you look at the mu s and mu k was less when compared to the mu s. Okay, so that is something that you need to know, right? You shouldn't have any doubt on the sum. This sum is obviously lengthy if you do it fully. But if you do it just the one part of this sum and you get the answer straight away, the sum is actually the smaller sum, okay? You shouldn't have doubt in the sum. Let's move on to the next one, which will be the final sum for this particular session, okay? This sum is based on the tension in the rope, okay? So this sum is a little bit lengthy also. Let's see what the sum is. A block A of mass m1 rests on a horizontal table. Okay, so you are having a block that is resting on a horizontal table. So that's the first statement. Then you have got a light string connected to it passes over a frictionless pulley. So you have a string that is connected to the first mass and then it is passing over a pulley. Okay, at the edge of a table, at the edge of the table, from its other end, another block capital B of mass M2 is suspended. So you are having one mass that is placed on the table and then you got a pulley on the edge of the table, and same way the second mass, which is like mass M2 block B, it is actually hanging. Okay, so hanging, which means it is getting suspended over there, okay, at the edge. Fine. So then what they're asking us to find is the coefficient of kinetic friction between the block and the table is mu k. So they have given you the kinetic friction in terms of variable itself, that is like mu k. So when you look at the option, it is pretty obvious. What we are going to find is a kind of like an equation with the variables. Okay, so that's what we are supposed to find over here. When a block A is sliding on the table, the tension in the string is, so what I need to get is, I just need to get the tension in the string. Okay, so first let me draw the diagram for what I have told you. So once I get that diagram, I'll just do the free body stuff into it, which means I'll just put all those forces and directions into it. Then let me frame the equation. So from that equation, let us figure out how to find the tension in the string. Okay, so let me first draw the diagram. So you are having a table and then you two have got an mass block A. Okay, so block A which has a mass m1 which is resting on the table, and then you got a pulley. So you got a pulley, okay, so at the edge of a table, and then there is this m2 mass which is hanging from that pulley. Okay, so that's the thing that they've given you over here. Okay, so frictionless pulley at the end of the table, from its other end another block B of mass m2 is suspended. Okay, so now I have drawn the diagram for the question over here. Okay, so now let me put the force balance thing into it. Okay, so here let me consider the mass that is on the table. So here you have got the mass m2 is going to pull this one with a tension T. Okay, obviously. Then what will you have on the table? You will have a friction that is actually acting opposite to the this tension, which will be like Fk. So when a block A is sliding, which means the block A is going to slide, which means you will have like kinetic friction. So that's going to be like kinetic friction Fk. Fine. Okay. So then what do you have? You will have M normal reaction N, which will be like acting upwards, and then same way you will also have M1G that will be acting downwards. So this is will be along the X, this will be along the Y. So along the Y you will not have any motion, therefore N will be equal to M1G. That's obvious, right? Next, let me do the force balance stuff for the mass M2. Okay, so here in this case I just pulled the mass M1 towards the right. Okay, so what will happen to this M2 mass? In turn it will get pulled towards the left. Okay, so I'm just pulling it towards the right, then it should get pulled towards the left. So here in the situation it is obvious, pulling towards the left means it is like pulling upwards. Okay, so these two things directions should be like opposite to each other if you stretch it. Therefore the tension here should actually act upwards, right? It should be clear, those two tensions should be opposite to each other. So regarding tension we have discussed exhaustively in the theory part. If you are just clear with that one, then this thing should obviously fall into picture. Okay, you should get this stuff. Okay, so tension will always act opposite to each other, right? Because on the one mass, if it pulls towards the right, the same mass will give opposite effect to the mass that is ahead of it, okay? Which means that it will pull the front mass backwards, okay? So those two things will be opposite to each other. As far as string is concerned, it is considered to be like massless, therefore there wouldn't be any force that is getting used for the motion of the string, okay? So that thing is considered to be like massless, right? It should be pretty obvious. So you have a tension that is acting upwards in the mass m2, okay? Same way, only one force will be there over here, which is like m2g, that will be acting downwards, okay? So if you consider it over here, what they are telling us is when a block A slides on the table, which means this is going to slide. In which direction will it slide? Obviously, M2 is going to dominate. Therefore, this will accelerate downwards. Okay. So this stuff is going to accelerate downwards. Then this M1 mass will accelerate towards the right. Okay. Okay. So now I have done the force balance thing for free body diagram for the mass M1 and M2. Now what I'm going to do is I'm just going to equate the forces along the x here and then forces along the y here, okay? Got it? Let me do it. So you'll have summation of forces along the x for the mass m1, okay? So summation of forces along the x for the mass m1 will be like m1a along the direction plus I cap, okay? It should be clear. Okay, so now if I do the solving, you'll have tension T that will be acting towards the plus I cap, and then you'll have minus Fk, yeah, that will be acting along the negative, which means plus minus I cap, which will be equal to m1a I cap, okay? So from this, let me take out all those I. So you will have T minus Fk. So instead of Fk, I'll put in mu k m1g, okay? Mu k, it should be clear, m1g, because from this normal reaction m1g, I'll substitute mu k m1g, okay? So instead of normal, I just put in m1g, so which will be equal to, that will be equal to m1a. Got it? So this stuff should be clear. So next what I'm going to do is I'm just going to do the force balancing stuff for the mass m2. So that will be like a summation of forces along the y, which will be equal to m2a, right? So we'll have like m2a, that will be like minus j cap. It should be clear, which will be acting downwards, okay? So here, if I do if I plug in those force balancing stuff, I mean forces stuff, I will have T2 that will act upwards, so that will be like plus j cap, and then you will have plus m2g minus j cap, which will be equal to m2a minus j cap, okay? So this stuff is done. So here it should be like pretty obvious. These two tensions are just the same thing, right? Therefore, I'll just remove this 2, okay? Because these two are opposite to each other. Therefore, you will not get T2 over here, right? You'll end up getting the straight T, right? So T j cap plus M2G minus j cap will give you like minus M2A. So if I put in that stuff, you'll have like T minus m2g, which will be equal to minus m2a, okay? So now I have formed two different equations, okay? So in this two equation, what will be the same? Acceleration is going to be the same, magnitude of acceleration is going to be the same, okay? So obviously I've plugged in all those direction properly, therefore a will be same, the magnitude. Same way tension will be same, the magnitude will be same. So here in this situation, what they're asking us to find is the tension in the string. If they're asking us to find the tension, then I'll equate the acceleration, because in both those cases, acceleration A was same. If I do equate those two things, I'll get the tension. If they're asking us to find the acceleration of this system, then what I should do is I'll have to equate the tension in the string, because tension is going to be same for both those masses, okay? So here in this case, they're asking us to find the tension, therefore I'll equate the acceleration, okay? So let me do the rearrangement accordingly. So if I do the rearrangement, you'll have like acceleration A, which will be equal to T minus mu k m1g divided by T minus mu k m1g divided by m1. So that will be the first one. Here you will have A which will be equal to, the negative sign goes over there, so we'll have like m2g minus t, m2g minus t divided by m2. Okay, so now I have got these two stuff. Okay, the acceleration. Then let me equate those two things. Okay, so if I just do the equating stuff, and if I just if I just rearrange it accordingly, I'll get the tension in the string. Okay, so let me equate those two things. Here you will have T minus mu k m1g divided by m1, which will be equal to m2g minus t divided by m2. Okay, so if I do have to equate this one, how should I do? I'll have to bring the t towards one side and then m1 and m2 on the other side, right? So what should I do is I should actually cross multiply this stuff, right? So if I do the cross multiplication stuff, you will have, let me cross multiply m1 and then the m2. So you will have something like this: t m2. Okay, so t m2 minus mu k m1 m2g, which will be equal to m1 m2g minus t m1. Okay, so this one is done. Now let me put the t on the left hand side and rest of the things on the right hand side. So you will have t, let me factor out the t, so you'll have like m1 plus m2, which will be equal to, if I put it on the right hand side, it becomes like positive, therefore you will have m1 m2 are going to be constant, right? So let me factor it out. So you'll have m1 m2g will just come out, and then you'll have like 1 plus mu k. Okay, so that should be the answer. So t should be equal to m1 m2g 1 plus mu k, right? And then this t will go to the denominator, right? Obviously this one will go to the denominator. So in the denominator you will have like m1 plus m2. So in all those four options in the denominator you have got like m1 plus m2, m1 plus m2, m1 plus m2. So obviously when this stuff goes to the denominator, you will have m1 plus m2 in the denominator. This thing is done, right? Same way, if you look at the numerator, it's like m1 m2 m1 m2 m1 m2. Okay, 1 plus mu k, right? So 1 plus mu k is the option 1. So option 1 should be my answer. So the answer for this one is like option 1, right? You should be clear with this sum, right? So this sum is actually the lengthy one. So here you have got like two different masses placed at two different positions. One is on the table and the other one is, and the other one was like hanging. Okay, so here the trick is tension will act opposite on both those masses because forces are opposite to each other. So in the case of the mass m1, it pulled it towards the right. Actually, in the case of the second one, it actually pulled it upwards. Okay, so that's how it was. So you should get this idea, right? We have discussed tension exhaustively in the theory part, so we should be clear with that stuff. So what we did is we did balance those two situations. With respect to mass m1, I just constructed a force balance stuff. Same way with respect to the mass m2, I did like force balance stuff. Okay, so when I did balance those two equations, the acceleration was not equal to 0. You had some acceleration. So when you had that acceleration, what was the tension? That's what they're asking us to find. Okay, so in this question, as they have asked us to find the tension, what I did is I equated the acceleration. When I did equate the acceleration, the only unknown parameter over there was like the tension. I just did the rearrangement stuff and I got the final answer. Okay, so you should be clear with this sum. So this sum is also a lengthy one, so you shouldn't have any doubt on this sum. It should be clear. In this session, we did see sums that were related to resolution of vectors, forces, and all those stuff. Okay, you should be clear with those kind of sums. They were easy. And we did start seeing sums that were related to friction. Okay, so the last two sums were a little bit complicated. Rest all other sums would have been easy, right? You shouldn't have any doubt in this. In these 10 sums that we have seen, it should be clear. So with this, the video is completed. Bye.